All right, so today we're talking about transformations of functions. So if you think about a transformation, right? Like if you ever watch one of those shows like Queer Eye or some style show, they'd be like, look at this transformation from before and after, right? They show the person before the makeover, and then they show them transformed after. So it's almost the same idea, but with graphs or functions. We're going to change them. Now you can argue if they're more beautiful or not. I'll leave that up to you. So there, we're going to focus on two types of transformations. The first one is a translation. So you should write this in your notebook, right? A translation means you're shifting the function, you're moving it. You're either taking the whole thing and moving it left and right, or you're going to take the whole thing and move it up and down. Okay? And the way you show a translation is you add a constant to the function. You're adding some number. Okay? So for example, first, we're going to talk about a vertical translation. So we're going to talk about what making a function move up or down looks like. So with lines, it's sometimes hard to tell, but we can still do this, right? So if we have the line y equals x plus 2, okay, there it is. Your slope is +1 and it crosses at x plus 2. What happens if I change this to y equals, so actually what I'm going to do is I'm going to call this f of x. I'm going to use some function notation. F of x equals x plus 2. So now what if I take f of x and add 3 to it? Not equals 3 plus 3. Well, what happens? Everything gets shifted up 3 spaces, right? The y-intercept went from 2 to now it's at 5 because 2 plus 3 equals 5. If I add 5 to it, it moves it up 5 spaces. Every single point moved up 5 spaces. This is a vertical translation. So if you add a number to a function, to a whole function, you move it up, okay? Something you can write down. And then the opposite is true, right? If I subtracted 5 from the function, the vertical translation means it moves down. You can see now the purple line, every point moved down by 5. Because what happened? When I added 5 to this function, it became x plus 2 plus 5, which means it's x plus 7. So the y-intercept's at 7. Or this one became x plus 2 minus 5. Well, 2 minus 5 is -3. So now my y-intercept's at -3. So that's what a vertical translation does. Moves it up or down. When you are adding a constant, it moves it up. When you are subtracting a constant, it moves it down. So this is what you can write. Vertical translations are added to the entire function. So this 2, if you start with 2x, that's a line, right? The y-intercept is just 0. So you're adding a constant k. So here, my example would be, since I'm adding 2, it moves it up 2. Right? We're here, we're subtracting 5. So what did we do? We moved the function down 2, or down 5 spaces, right? So it's been transformed. It moved up and down, okay? So that's the vertical translation. You can also have translations that move the function left or right. So all that's different here is instead of adding or subtracting a number to the whole function, you're only going to add or subtract it to the x value, okay? Because we're only wanting to change the x value, the left and right. So when I come back, let's look at this first. So if I wanted to change these functions from the original function, right? I could say, I'm going to make this new function g of x, and it's going to be equal to x plus 2 and then plus 2. So this is really hard to see with a line. So what actually, I'm going to show you something different. So let's say you have this function x squared. This is what it looks like. It's a parabola. It doesn't matter that you don't understand it. We haven't learned it yet. It's fine. But what I mean for a horizontal translation is that what's happening is instead of, like here, if I add 5 to the whole function, you see it moves up 5, right? Instead of adding 5 to the whole function, what if we just add it to the x? So x plus 5, and then all of that is squared. Well, if I just add that to x to the 5 to the x inside the parentheses, right? It's happening just to the x. You can see that the points all move from here to here. So they moved to the left 5 spaces. So adding 5 just to the x moves the graph over to the left 5. And guess what? If I make this other function, let's say it's x minus 5, the whole thing squared. So now that I've subtracted 5 just from the x, it moves to the right 5 spaces, right? So it went from here being at 0, 0, now it's at 5, 0. So horizontal translations do the same thing. They move them left and right, but you're only adding the number to the x. That's the first important thing. And then the second thing, it's the opposite of what you think. When you add to the x, it actually moves it to the left. And when you subtract from the x, it actually moves it to the right. And this has to do with inverse operations and solving equations, which we can go over an explanation if you want to, but really that's just kind of the pattern you have to remember. And it's really hard to see this with lines, moving them left and right, because it also means the points kind of move up and down. I find it easier to use nonlinear equations for this. So if we come back here, you can write a horizontal translations are only added to the x, right? Only when the constant is added to the x. So here, you can see this plus 2 is only being added to the x. So what does that do? It moves it left 2 spaces. Remember, it's the opposite of what you think. Plus 2 means we're moving it to the left. Here, the minus 5 is only happening to the x. It's not happening to the whole equation. So what does that mean? That means it's the opposite of what I think. So this minus 5 moves it, or moves the function, if you want to be more clear, right 5 spaces. Okay? So if this were if this is a horizontal translation, so this is how it would look if it was a vertical translation, right? That would be on the entire function. This is only happening to the x. Okay? Just wanted to show you the difference. Okay, translations are kind of the easiest, right? Because you're just moving it up and down. So if I look at this, what we're going to do is talk about the translations we see. So the original function is 2x minus 4. It has the y-intercept of -4, and it has a slope of 2. Okay, well, what's happening? Just to the x, a 5 is being added. So this means if it's just to the x, that's a horizontal translation, right? Translation. And then horizontal translations are the opposite of what we think. So if it's plus 5, it's going to mean that we're moving left 5 spaces. Okay? And let's see if I can get this to graph 2x minus 4 and 2x plus 5 minus 4. So you can come over here and see, here's our original function, 2x minus 4. And when I added that 5 inside the parentheses, it moved it over to the left 5. Everything moved left 5 spaces. Okay, so the next thing that we're going to talk about is a little trickier. It's called a stretch or compression, right? You can stretch things out and make them skinny, or you can compress them and squeeze them and make them fat, right? It's another transformation that you can do to graphs. And this happens by multiplying by a number. Not adding or subtracting anymore, we're multiplying. Okay? So I'm going to ignore this for right now, and I'm going to come back to my graph, and I want to show you guys something that's a little easier to see. So remember when we had this function y equals x squared and made this parabola, this curve. So what happens if I multiply this whole thing by 5? When I multiply the whole thing by 5, this new blue line is now skinnier, right? It's been vertically stretched. It's nice and thin now, right? So when you multiply by a factor that's greater than 1, has to be greater than 1, you're stretching it out, you're making it skinny, right? And then what about if we make it a fraction? What if we say y equals 1/5 times x squared? Oh, there's our new function. It's been transformed to this green line. It's nice and big and plump now. Someone has squashed that thing down. It's compressed. So when you are multiplying by a factor, if you multiply the whole function by a whole number, it makes it vertically stretched, nice and skinny. If you multiply the whole function by a fraction, it makes it plump. It's called a vertical compression. So let's write that down. What you really want to write down is this. So I want to add this here. We're going to ignore these examples right now. So if you multiply the entire function by a constant, it's a vertical stretch or compression. Okay, so you see that it's being multiplied by some number, so I know it's a vertical stretch or compression. And then you come down here and you go, okay, if the number is greater than 1, it's a vertical stretch. And if that number you're multiplying is between 0 and 1, right, it's a fraction, then it's a vertical compression. Those are the things you want to write down. You want to write this first. You can almost show it as being something like this. F of x equals k, some number constant times some other function, right? So this k is your multiplication factor, your vertical stretch or compression. And then if that number is greater than 1, it's a vertical stretch. If it's less than 1, between 0 and 1, it's a vertical compression. Okay, so you can have the same thing. Now you can have horizontal stretches and compressions, and really they're almost the opposite of vertical, right? Because if you look at this, well, the whole time I was not even showing you this. Let me come back and show you what I wrote. Apologies, hopefully you're following along what I was saying. So if you multiply the entire function by a constant, it's a vertical stretch or compression, right? K times g of x. And then if that number k is greater than 1, vertical stretch. If that number k is between 0 and 1, it's a vertical compression. One thing to note is, like, when I'm looking at this is a vertical stretch, right? This blue line, but I could also think of it as a horizontal compression because it's already being squeezed from side to side. Versus this green line, this green curve, is a horizontal compression because it's like someone standing on top of it and squashing it down. But at the same time, it's like a horizontal stretch because it's like someone's taking the two sides and pulling it out. So you can use those words inversely to talk about things. So sometimes it gets a little confusing, but both people can be right. So we're going to go back to this tab and we're going to talk about horizontal stretch or compression. So just like in a horizontal translation, right? If you added it just to the x, that's how you move it left and right. Well, the same thing is true with a horizontal stretch or compression. You have to take your multiplication factor k and it happens just to the x, right? So for example, I'm going to write this same thing. If you multiply just the x by a factor, let's call it k again, then it's a horizontal stretch or compression. So that would be like if you take your function, your new function f of x, and all you do is take every x in there and multiply it by k. So just the k is getting multiplied by the x, right? Not the whole function anymore. It's happening inside the parentheses. So if this number k is greater than 1, it's a horizontal compression. And if it's between 0 and 1, right, it's a fraction, it's a horizontal stretch. So again, it's the opposite of vertical. Okay, so if I was writing this, I might write this note here, right, talking about horizontal stretches or compressions. Then I have an arrow saying, when is it a horizontal compression? And then I might have an arrow saying, okay, when is that thing a horizontal stretch? And like I said, it's the opposite of the last one. Now I'm going to come show you in a graph. So I'm going to use the curve because I think the curve's easier to see. So here was a vertical, right? Because 5 was being multiplied by the whole function. It's essentially this, right? 5 times x squared. But now what we're doing is we're multiplying just the x by 5. Keeping that in parentheses. We're multiplying just the x by 1/5. Okay, so let's see what happens here. So you can see that when you multiply just the x by 5, this blue line, it's been squashed from a horizontal perspective, right? It's like someone took the sides of it and pushed it in. It's a horizontal compression. Where, when I take just the x and multiply it by a fraction, it's like someone grabbed the curve and pulled it out. It's a horizontal stretch, okay? All right, so this little table here is something that might be helpful for you. So it's like a synthesis of all of our work, like all of my notes. So you could take a screenshot of it, you could pause it and write it down. It kind of synthesizes everything we did. And then you are going to practice this today. So today is really, this lesson is hard because it's got a lot of vocabulary. Okay, you're learning new words and trying to figure out how you see them in graphs. But we do translations in Algebra 1, you do transformations in Algebra 2, and you do transformations in pre-calculus. They're always coming back. This is your first dip into it, okay? So it's all right if it seems a little bit tricky now, and we're gonna work through it together. And you guys have the power and the tool of Desmos. So whenever you get stuck, you can always graph it and be like, well, what's happening? Is it moving left, right, up, or down? Is it being stretched or compressed? It is a lot harder to see stretches and compressions in a line, right? Because it still looks like a line. That's why I showed you the curve. So a little practice today, and I will see you next time.